All right, guys, so how are we? I'm not really sure how Monday's class is going to be going over this, but here's the do now for Monday's class. I'm going to create this video just because I'm not sure how going over this will be. So hopefully this will help those of you at home and maybe even those of you actually in the class. All right, so you got these three vectors on this piece of paper or on the screen. And the first thing it says, and this is the first thing you should always do, is find the components of each vector. So here's how you do that. You're looking for the three vectors. A, eraser, A sub x. Actually, hold on. Let's make that skinnier. All right. A sub x. A is pretty obvious. It's just 6 meters. A sub y is also very obvious. None of that 6 is up or down, so that is just a 0. B sub x and B sub y a little different. B is, let's say, 12 meters at 60 degrees, 12 meters in this angle. So some of that 12 is sideways and some of that 12 is upwards. We got to figure out which ones. That kind of creates a little right triangle there. And using our trigonometry, the sideways piece of that 12 is adjacent to the 60-degree angle. So it would be calculated by 12 meters multiplied by the adjacent side is the cosine of 60 degrees. Cosine of 60 is a half, so that's 6 meters. The vertical piece, the y direction of that vector B, is opposite the 60-degree angle, so that's going to be sine. So you get 12 meters times the sine of 60 degrees, and that equals 8.66 times 12, 10.4 meters. C is a different one. Whoops, what the heck am I doing there? Let's first get rid of this. And now let's go C sub x and C sub y. First thing I want to point out, C is very interesting. If this is the origin, C is down. It is still to the right, but now it's down. B was to the right, but up. So here's some very, very, very important conventions that you need to know about. Everything to the right, or let's say east, we consider those things to be positive. Everything that is to the left, or we'll say west, that is going to be negative. And also that would go true with up or north. We consider those positives. We also consider everything down and south negative. All right? Up and north are positive, down and south negative. Important things to know. Convention. So C is to the right, so the x part is going to be positive, but it's down, so the y will be negative. All right, so back over here. C. Sum of C is to the right and sum of C is down, so we're going to break that into two pieces. The sideways piece of C, the piece of C that's to the right, is adjacent to the 60 degrees, so cosine of 60 is a half times 9, so this is going to be 9 meters times the cosine of 60 degrees, and you're going to get 4.5 meters. The y, you have to think, right? Because if you just do the math, you're going to go 9 meters times the sine of 60 degrees, and you plug that into your calculator, you're going to get positive value, but you have to look at that picture and know that it is negative. If you really want to be crazy about it, you can get a negative because that angle, I shouldn't have put in there, 60. Going from the origin, it would be 300, right? So you get this, by the way, you end up with -7, because it's down. Let's go 7.8 meters, but it's negative. If you were to use the angle of 300 sine, you get negative 0.866. Multiply that by 9, you get your negative 7.8. So if you wanted to do it that way, you could reason that this angle there would be 300 degrees. And that would give you if you use that angle, you get negative result. All right. The rest of this now is really pretty simple. I'll walk you through A plus B, and then that's it. The rest you can do on your own. I think that'll be enough. But the way to solve this, let's pick a nice color here. Now we go A plus B. That's going to be A sub x plus B sub x, and then A sub y plus B sub y. You can do this graphically. In class, you've probably heard me say this, and if you haven't heard me, you're going to hear me say this a lot. You add vectors tip to tail. You add vectors tip to tail. These vectors are drawn wrong. These vectors are drawn all from the origin, so the tail of each arrow is at the origin. That's incorrect. When you do the arithmetic to them, you have to draw them tip to tail. So to draw A plus B, let's say you'd start with A, which is an arrow like that, and then B, if you were to take the arrow that's B and start at the tip of A, B goes off in some angle like that, not steep enough. Try and do it to scale, something like that. The resultant would be from where you started to where you finished. The answer is going to be something like that. Some arrow looks like this. Here we go. A sub x, we figured out, was 6 meters. B sub x is 6 meters, or 12 meters. A sub y is 0, and B sub y is 10.4. So that's 10.4 meters. So when you come over here, if you think about this one here, this is going to have a sideways piece of 12 meters and an upwards piece. Draw that, not even close to it. Upwards part, 10.4 meters. So now you can use your A squared, B squared, C squared, you use your Pythagorean theorem, right, to figure out the A plus B. Basically, you got a triangle looks like this. 12 meters, 10.4. You want to figure out what this one is over here, right? 12 squared plus 10.4 squared equals that. Take the square root of those things. 15.9 is the magnitude. The magnitude of this is 15.9 meters. Always carrying units through. But you also need to know the angle between them. What is this angle? All right, what is this angle here? Tangent theta equals 10.4. Tangent is opposite over the adjacent, 12 meters. Tangent theta, 10.4 divided by 12 gives you some number. You get tangent theta equals 0.8666, a bunch of other numbers. Invert tan or arctan. Make sure your calculator is set to degrees and not radians. Sometimes in math class, your calculators are set in radians. You should get theta equals 41 degrees. So A plus B. How do you figure this out? A plus B. A plus B is equal to 15.9 meters at 41 degrees north of east. And that is the answer. All right, guys.